My name is Mutra Enoch, and we are going to revise together circular motion. As we know, circular motion, that is just the start of objects that are rotating about a fixed point. Under circular motion, we are going to focus much under banked motion. So we have the question which is saying a race car is moving on a road that has a banked curve with 31 degrees tilt and with radius of 316 meter and negligible friction. So the first question they are saying, calculate the speed of the car. So what you have to understand is that before you start answering, let me first drive the formula that you are going to use under banked motion. So say solutions. So let's consider this is a banked curve where that racing car, let's assume our racing car was here, and then the angle it was making that was 31 degrees. So from here I'm going to resolve. We have the normal force here. This racing car was exerting the weight force downward, which is mg. Apart from that, I'm going to extend this vertical normal force. So after extending, I'm having the angle here to be theta. And then this force here is what we call the normal force. So if I resolve this normal force in vertical and in x-axis, in vertical axis, I'm going to have normal cos theta. And then in x-axis, if I resolve this normal, I'm going to have normal sin theta. Now, to balance this force, I'm going to put centripetal force this way. So centripetal what? Centripetal force. Now from there, what am I going to do? I'm going to abide to what? To the summation of forces in vertical or in y-axis, also summation of forces in x-axis. So I'll say summation of forces in y-axis is equals to 0. So I'll assume going up that is positive. So I'm having n cos theta minus mg is equals to 0, where my normal times cos theta is equals to, when negative mg crosses the equal sign to be mg, positive mg. And then apart from that, I'm going also to do the summation of forces in x-axis. So summation of forces in axis is equals to 0. So I'll assume going this side, that is positive. So that is Fc minus n sin theta is equals to 0. So making Fc or centripetal the subject of the formula, that is Fc is equals to n sin theta. So what am I going to do? I'm going to make n the subject of the formula here by dividing with cos theta over cos theta. So I'll cancel there. That is n is equals to mg cos theta. So this simply means that where there is n, I'm going to replace with what? Mg over cos theta. So that is centripetal force is equals to mg over cos theta multiplied by what? Sin theta over 1. So apart from that, we know to say centripetal force as its own formula, which is centripetal force is equals to mass velocity square over what? Radius. So this mass v square over r is going to be replaced where there is this centripetal force. So that is mv square over r is equals to mg over cos theta dot sin theta over 1. So here that is, this mass is going to cancel with that mass. I'm going to remain with v square over r is equals to g sin theta over cos theta times 1, that is cos theta. So now, this is the trig identity. Sin theta over cos theta, that is tan theta. So v square over r is equals to g tan theta g. Now making v the subject of the formula, it is going to be v square over r is equals to g tan theta. So over 1, you cross multiply, that is v square is equals to r times everything there, r times the numerator, that is rg tan theta. So making v, or the formula for velocity, I'm going to square root both sides to kill this square. So that is velocity is equals to square root of rg tan theta. Now, the first question is saying we calculate the speed of the car. So this is the formula that I'm going to use to calculate the speed of this race car. So I can now start answering. So that is velocity or the speed of the car is equals to square root of our radius, that is 316, multiplied by acceleration due to gravity, that is 9.8, multiplied by tan the theta, which is the angle we have been given to be what? 31. So velocity is equals to, if you multiply everything inside there under the square root, what are you getting?
1860.75.
So 1860 point what? 75, no?
Yes.
So the square root of this number, what are you getting?
43.14.
43.1 meters per second. So this is the solution for question 1. So we can now proceed to question 2, where they are saying find the necessary centripetal acceleration on these scales so that the car won't tend to slip down or slide up on the incline. So the formula for calculating the centripetal acceleration, so this is A, B. So centripetal acceleration, that is, acceleration is equals to v square over what? R. So acceleration is equals to the speed you have calculated to be what? 43.1, you square over the radius, which is 316. So therefore, your acceleration is going to be what? the final answer for acceleration. What are you getting?
5.89.
5v.89. 5v.8. 5.88 meters per second square. So this is the final answer for what? Acceleration. So we can proceed now to the third one. Let me just wrap this part to create the space. So the last question or the third question, they are saying if the banking above was changed to the radius of 245 meter, what should be the angle of the bank to allow self-travel around the curve at 58 meters per second? So we have been given the what? The speed, and then also the radius, and then we are taught to calculate what? The angle. So we are going to abide to this same formula. So since we have the speed, so our speed, that is 58 meters per second, the radius, that is 245 meters. And then we are taught to calculate what? The angle. So it's just the matter of replacing. So that is speed 58 is equals to the square root of what? Radius, that is 245, multiplied by acceleration due to gravity, which is 9.8 times tan theta. So to kill this square, I'm going to introduce, to kill this square root, I'm going to introduce a square to both sides. So that they are going to cancel each other. So 58 square, what are you getting?
3364.
3364 is equals to 245 times 9.8. What are you getting?
2401.
2401 tan what? Tan theta. So making tan theta the subject of the formula, we are going to divide both sides by 2401 over 2401. So you are going to cancel. So if we divide 3364 over 2401, what are you getting? 1.40 is equals to tan theta. Making theta the subject of the formula, this tan is going to cross the equal sign. Whenever any trig ratio crosses the equal sign to become the inverse, so it is going to be theta is equals to tan inverse of 1.40. So our theta, that is what?
54.5 degrees.
54.5 degrees. So this is the final answer. So if you have found this video interesting, don't forget to like, also comment. If you have any queries, contact me using the WhatsApp line, which is 0764 76 55 39. Thank you so much. See you in the next video.